We're now going to talk about multiplying radicals. Okay, so multiplying radicals, we're going to use the multiplication principle. So multiplication principle says if you have two things with the same index, then you just multiply the numbers inside. Now for this, it looks like you only have two things being multiplied together, but in actuality, we have four different things multiplied together. And so because we have four different things, we're allowed to rearrange the order any way we want with this. So what I'm going to do is I'm going to put the numbers together and then the cube roots together like this. Now, what you might be thinking is, wouldn't I just take 5 cube root of 4 and multiply it by the 3 and then multiply it by the radical 14? So that's only going to be the case if you've got a plus or a minus sign between the 3 and the cube root. That's like this other problem down below that we're going to do right after this one. There's pluses and minuses that's done differently, but this is just straight multiplication. There's no adding, subtracting here at all. So because all this is multiplication, that's really four different things you're multiplying, and you can rearrange the order like I did here. So now we'll multiply the 5 times 3, and that's going to be 15. But then we're also going to multiply these two together, and we get cube root of 56. Okay, so cube root of 56 we get now. All right, so now the thing is we have to just try and break this down into perfect cubes if we can. Okay, so 56 here. Well, we can just go ahead and use 4 and 14 because we already see that that's a factor because we just multiplied those to get that. The 4 breaks down into 2 times 2. And then the 14 is 2 times 7. Now we're looking for a group of 3 of these because it's a cube root now, and that's 8. So of course 56, yes, is 8 times 7. So what I would do in my next step is I would rewrite this as 8 times 7. So you might not have thought of that right away to know that 8 is a perfect cube. But that's the way you would do it if you didn't recognize right away and you just use the original 4 times 14, or maybe you might have divided it by 2 and started with that pair instead. So again, there's more than one way to arrive at the same result. But either case, I want to get down to 8 times 7, and 8 would be the largest perfect cube that I would have here. So I'm going to do cube root of 8 times the cube root of 7. So cube root of 8 would be 2. Right there. 5 times 2 is 30. And so that would be the answer, 30 cube root of 7. And that's nothing more I can do with that one. Now, the next problem is different because we have pluses and minuses that we're multiplying together there. Okay, so for something like this, what I'm going to do is I'm going to multiply this in a certain order. What I'll do first is I'm going to take this. I'll multiply the first term by the first term there, and then I'm going to take the first one and multiply it by this one here. I'll do one at a time. So let's just do one at a time. I'll do the arrow separately just so you can see what it is that we're doing so you don't get confused. So the first thing I'm going to do is do cube root of 4 times the cube root of 4. So that's the first thing I'll do. The next thing I'm going to do is I'm going to take the cube root of 4 times negative 3. Now, when you multiply something like this, the 3 does not end up inside of the radical. Now, the reason why it doesn't work is because, remember, this is not we can't use the product property on this like we did before in the previous example because you have a number that's being multiplied by a radical. So in this case, you would just put minus 3 and then times the radical, the 4th root of 4 you'd have. All right, so that's all you can do on that. Again, 3 doesn't go inside. You just have to leave it outside like this. Now, let's erase these because now I want to show you what the next two things are that we're multiplying. So we did the first one times these two, but now we're going to do the second one times these two. So now we have 3 times the radical, and then we're going to do 3 times the last one. So 3 times the radical of that, it's going to give you 3 times the 4th root of 4. And now I'm going to do 3 times negative 3, and you get a minus 9 there. Now let's multiply these here. So see how these two things are both radical 4s, or the 4th root of 4? Those you can combine together. So if you do that, 4 times 4 is 16. So that's the first two multiplied together. Now these middle ones, you have a -3 and a +3. They actually cancel out. And the reason why is because they add up to a 0. -3 and +3 is a 0. 0 times anything is 0. So that whole thing, middle terms, those are going to be gone. But you still got the -9 on the end here. Now the fourth root of 16, you can actually do that because 2 to the fourth power is 16. So this will turn into a 2. We have 2 minus 9, and the answer is going to be -7. All right, so that in this case, we don't get a radical at all. We actually get a whole number or answer as a result. We get an integer as a result. So -7 we get. Now we're going to do the same thing on this problem. It's going to be another problem where, so let me write, I'll show what we'll do. First, we're going to do this. So we're going to do the first one times 3 radical 2, then the first one times 3, but then we're going to do these as well. We'll do the bottom one, or the second one times 3 radical 2, and then the 7 times the 3. Let's do all that in order. So let's first start with, again, I'll show these. I'll just do these in order so you can kind of see what we're doing. So we'll start with this. Now, if you multiply that, we have 7 radical 2 times 3 radical 2. I'll do that in the next step, so I'll just leave that as is. Now we're going to do 7 radical 2 times 3. Now remember, the 3 can't be multiplied inside the radical. You can only multiply the number on the outside. So 3 times 7 will give you 21. So we have 21 radical 2 there. Now let's do these. This is going to give you another 21 radical 2 because you have 7 times 3 again. Again, 7 can't be multiplied inside, but you can multiply the numbers on the outside there. And finally, we're going to do 7 times 3 here. So we get plus 21 there. Now let's go ahead and combine this. So these two, if we multiply these first two together, I'm going to do the same thing I did for that previous problem. I'm going to go ahead and rearrange these and put the numbers and then the radicals first. Now these two middle ones, these are like terms because they both have a square root of 2 on them. So we can combine those together. 21 and 21 is 42. So you get 42 square root of 2. And then you have a 21 in the end there. 7 times 3 is 21. Now this here, radical 2 and radical 2, if you multiply those, it's going to give you a radical 4. And the rest of this, we'll go ahead and leave that. Square root of 4 is 2. So now that's going to turn into 21 times 2. Again, the rest of this, we'll keep this all the same. 21 times 2 is 42. So 42 plus 42, radical 2 plus 21. Now 42 and 21, those are like terms, so we can add those together. 42 and 21 is 63. So we get 63 plus 42 radical 2. That would be as far as we can go now because there's no more like terms for that. One has a radical and one doesn't. So that would be as far as you can go.